I want to introduce you guys to the stereographic flat Earth model. Stereographic means there's two poles on this map. And that's a really important thing because it gives us an Antarctica that is represented the same way as the globe. Now, this matters because if we want to have Antarctica as that massive ice wall surrounding us, we need to be able to argue why the measurements don't show that. For example, there's yacht races that are in Antarctica, and these people seem to measure a distance that does not represent the Gleason model, but does represent the globe map. And this becomes a problem because if the measurements are accurate, how does that then work on a flat Earth? It's also a problem because there is no curve. We know there's no actual spinning ball in space, so then how do we model that on a flat Earth? Now, the stereographic map makes a lot of sense. It doesn't even require a dome firmament, and you're going to see why as well, because it's based on idealism, which is another term for simulation theory. So you have to understand that we're not talking about materialism. Idealism is the belief that consciousness comes first and physical reality is a result from that. Now, I want to show you something. This is the important part here. See what happens when I pass the boundary? So what this means is that you can circumnavigate on a stereographic map. The math behind it is extremely easy. It's only these 8 lines of code right beneath me. And pretty much all it says is if you go past one side, you'll reappear on the other. And that is what we observe on the flat Earth. For example, people have claimed to circumnavigate the South Pole. Whether that's true or not, we will never know unless we do it ourselves. But it's important that we can make a framework that allows this to happen without everyone having to lie. For example, even Australia. It would be nice if there was a flat Earth model that gives us Australia at the exact same size as what the globe claims it is. Now, this matters because people measure Australia and they have no belief in the globe. They don't know any different, but it can be confusing for them. How does this make sense on a flat Earth? And that's been a problem for a long time in our community. How do we get an accurate map of flat Earth? The stereographic map solves that completely, especially in terms of astronomy, where you have the north celestial pole and the south celestial pole. On the Gleason map, where you have the dome firmament, looking in different directions south, you can still see the Southern Cross. The right ascension will be different. But in order to reconcile how it appears in multiple directions, we still need to employ simulation theory. Now, for those of you who don't know what I'm talking about, you'll want to go to the Journal of Geocentric Cosmology. There's a paper called Declination and Right Ascension. This explains it explains what we have to do to make the Gleason model work so that we have an accurate celestial sphere. This is also similar to 2017, where Walter Bislin, also known as the Shane model, made the celestial sphere and different directions south, like literally facing one direction south on flat Earth and facing the exact other direction south, you can see the exact same Southern Cross. So no matter what, we know that the physical world is not real. So that's called materialism, and people who believe in the globe conspiracy theory are often stuck in a materialist mindset. They can't think outside of that, and that's really why they tend to get emotionally upset and respond in the way they do. So you'll want to understand idealism, that consciousness came first and the physical world we see is a result of that. A really nice way to say that is that I'm living in universe A you're in universe B. Together right now we're sharing universe C. This allows us to understand, such as maybe the sun actually is setting in the water. Maybe the sun actually is between the clouds. We can do a lot of stuff once we get past the materialist mindset. What I really, really like about this model is that circumnavigation becomes possible. You can go to the South Pole. I just circumnavigated it again, and you can go any direction. So let's circumnavigate the South Pole this way. And this is what people experience. They just imagine that they're on like a ball going around that. That's what they actually believe, though. We know it doesn't make any sense. But on a stereographic virtual reality, it makes perfect sense why they can circumnavigate and keep on appearing on the other side, even though there's no actual curve. So this is where my research is going to be taking me right now. I'm fascinated by this model because I don't want to have to believe that everyone's lying. I like to believe that the scientists who went to the South Pole actually did an accurate measurement, but they just don't know any better. Similar to how Einstein improves on Newton. There was a time in the 50s where scientists were actually trying to argue against atoms, saying atoms don't exist. So it's important to understand that scientists really don't know anything, and the obligation is on us, those of us who are senior flat earth researchers. We determine what is true and false. Scientists can only really do what they're paid to do. A globe conspiracy theorist funds their project. The conclusion's always going to be a globe. And they're not necessarily wrong. It makes sense, right? So see this flat model? If you're told you live on a ball and then you go to the south and you're now on the other side, you're going to think you live on a ball. It's not that you're stupid either. I don't think scientists are stupid. They only know the limited information that they know. It's often called the Dunning-Kruger. They only know a little bit, and then they form these vast conclusions based off of that little bit of knowledge they have. So this is really fascinating. And it's accurate. This is accurate, and you can measure the latitude and longitude lines for distance, and it will be accurate. It gives us an accurate Australia. It removes the dome firmament. For example, why do we even need a firmament? Why do we need it? That's still thinking in the materialist mindset. We don't. And then why do we need an Antarctica ice wall? The only reason why we thought there was an Antarctica ice wall is because we were in the materialist mindset and we were using the Gleason map, which is often promoted by Freemasonic shills such as Mark Sargent. Do we even know if that's an accurate map? I don't know. So this is where I want people to start focusing their research on. I'm going to provide the map in the comments. You can download it, study it yourself. The model is also going to be free. Flat Earth University, we're a nonprofit, so we're just trying to help increase the academic knowledge and help make a better future for our youth. So you can go to model.flatearth.university/stereographic. Load this for yourself so you can like walk around and control it. If you have a game controller, you can plug it into your computer. It's really, really cool. The way web browsers work, there's something called the Gamepad API. So it'll automatically work. This is a safe way for me as a developer to interact with interfaces. So yeah, plug in your game controller and it'll work instantly, and you can control it around, move around, explore this. Go to the South Pole, try to circumnavigate, see what happens. It's really, really cool, and it explains a lot of stuff. It really, really does. So just to clarify, this removes the Antarctica ice wall so we can use the well-known measurements. This removes the concept of a firmament so we don't need that limitation anymore. And it also gives us the accurate southern hemisphere. For example, Australia is the size that people believe it is. Otherwise, it makes us have to argue a lot of stuff. I have to then argue, why is Australia 2.5 times larger? Is it actually that size? And on the globe, is it just 2.5 times smaller? The globe could be wrong. We don't know. And these are theoretical frameworks. But I'm fascinated by this. You can't really argue against this because it is an accurate flat Earth map. It's accurate. It works. It solves everything. Circumnavigation, the ice wall, land sizes. It's amazing. So if you have any questions, feel free to let me know your thoughts. It's amazing.